Stanford University.
Okay, well, welcome to Stanford CS 193P, developing applications for iOS. It's winter quarter 2017, and today we are going to talk about a few things. So we're going to start off, though, giving a demo about what I talked about last time, which is multiple MVCs. After that, I'm going to do some slides on the view controller lifecycle, really important mechanism for finding out what's going on with your MVC as time flows by. And if I have time left at the end, I'm going to start talking a little bit about memory management, basically managing the memory of reference types, things that are in the heap. How do they get managed? How do they know when to stay in the heap or leave the heap or whatever? Okay, but first we're going to start with this demo. Okay, I'm calling this demo Emotions in Faceit. If you remember last time, we built a nice MVC that knows how to draw a face. It was a pretty generic MVC, and it had a model, which is a facial expression. So now we're going to build a more complicated app that has two MVCs. And one MVC is going to let you choose an emotion, like happy or sad, and then the other MVC is just going to be our generic face view, right? And it's going to show that emotion. So by doing that, we're going to learn how to use the split view controller, navigation controller, all that, and combine MVCs to make a bigger app. It's a simple example because of time constraints, but you should get the idea. So here I'm back in Faceit, this demo we had last time. And one thing before I start, I wanted to show you something you're going to need for your homework, which is how to rename a view controller. You see I have this view controller here. This is the view controller that shows the face, right? Remember, here's the face view var, and here's its model, the expression or whatever. So I don't like this name view controller. It's really way too generic. It's almost like its superclass, which is UI view controller. Really, this wants to be some specific named view controller. And in this case, it shows a face. So this is probably best called the face view controller. So I want to just type face right here and hope that that's enough. But of course, as I mentioned in like lecture number 1, that's not enough. Okay, you can't just rename it right there. You actually have to rename a couple of other things. One, the file that it's in, you see the file is still called viewcontroller.swift. We almost always want to have our name of our file be the same as the primary class that's in there. Now, it's not required in Swift. The name of the file could be completely different than any class in there. But generally, to kind of help people find the code they're looking for, we want to have the name of the file pretty much match the name of the main class. There could be multiple classes in a Swift file. That's perfectly allowed as well, but if it's the main one. And you might think, okay, well, that's enough. But there's one more very, very important piece of this, which is in the storyboard. Okay, and we haven't really talked too much about this, but you're going to see it well, actually, we did see it with the face view. Okay, we did this with face view. But we need to inspect this controller, and I'm going to click on the controller by clicking this orange thing up here. Okay, that represents the controller for this whole MVC. And I'm going to go over to this same inspector we went on when we changed the face view from being a generic UI view to being specific to face view. And I'm going to do the exact same thing here. So I'm picking this whole view controller, and I'm going to identity inspector up here, and I'm going to change the class from view controller, that's what it was, the generic name, to face view controller. Okay, so if you forget to do this piece, then none of your outlets are going to be hooked up, and iOS is going to be very confused because you're going to be asking it to hook up outlets to a different class. Some classes doesn't exist anymore because I renamed it away, okay, view controller. All right, so you'll need to do that for your homework. You'll have to change your current calculator MVC from being called view controller to being called something like calculator view controller. And that's because you're going to have this new MVC, the graph view controller, and you want to make clear which one is which. Okay, now I'm not going to touch my face view controller or MVC at all in this demo from here on. Okay, so I'm going to build this multi-MVC app, and I'm going to use the face view controller that finished building last time as a reusable component, just like your graph view controller is going to be a reusable MVC in your homework. All right, so I said that I wanted to have two MVCs. One is just a list of some emotions, and then I'm going to use this MVC to show that emotion. So let's just dive right into this and put another MVC into our storyboard. So we have this one MVC. We get another one, in exactly the same way that we get like a new button or something like that, which is to go down here to the utilities window at the bottom here and just drag out a view controller. You just pull it out and drag it right into your storyboard like that. Now, this MVC right here, what's going to be its class of its controller? It's just going to be, if we select it by clicking on the orange thing, UI view controller. In other words, not a subclass. So we're going to need to create a custom subclass for this view controller, just like we have for our face view controller. Okay, and we'll do that in a second. Before we do that, though, I want to talk about this little arrow. You see this arrow right here? This is the arrow that tells iOS, when this app launches, use this MVC as the first thing that appears. Okay, so it's like the entry into the storyboard. And so if I want it to be the other one, I can just pick it up with the mouse and drop it on that one. And now this one is my entry MVC. I also want you to notice that we have a warning here. You see this yellow warning? I'm going to click on that. And we'll see here it says face view controller is unreachable because it has no entry points. Okay, it's saying this view controller right here with the face, you're never going to see that in your app. Okay, which is true because my app is going to come in here to this blank one and I can't get to the face view from there. Now, of course, we're going to add a split view controller and navigation controllers. We're eventually going to be able to get there, but I just want you to understand what this unsupported configuration means. It just means that you can't get there. And if I move this back, this arrow off of this and back over to here, now this one, you see, view controller is unreachable, okay, which makes perfect sense. All right, now, and if I run this app, by the way, let's go ahead and run, you're going to see that my app's going to come up completely blank. That face will not be there because that MVC is really not even being used. It's in the storyboard right now, but since it's not accessible, we can't navigate to it, we can't segue to it, to use the terminology you learned last time. We get this completely blank UI. All right? Now, if we want to have things like outlets and actions or anything like that with this view controller, it needs to have a custom subclass of UI view controller. It can't just be generic. So we're going to create that. We're going to go to File, New File. Remember, that's always where we go when we create a new UI view subclass, a new view controller, any calculator brain. We did all of those from New File. So I'm going to click New File. This is going to be a subclass of an iOS class, UI view controller. So I'm going to pick this one here, Cocoa Touch class. We used Swift file over here when it was just calculator brain, not a subclass of anything. But here we're going to do Cocoa Touch class. And it says subclass of what? Okay, it's even defaulted here to UI view controller. Remember earlier we picked UI view. We're going to leave this UI view controller. And I'm going to call this view controller my emotions view controller, okay? Because it's going to show the emotions like happy, sad, whatever. And then I'm going to click on it to go show the face. So I just do that. Go over here, it says, where do you want to put it? Again, I do not want to put it here. You see where it says group, face it, and it has that blue icon? We want to put it down in here. Because if you put it here, it's going to be at the very top level. Down here, it's with all your other classes, face, view.swift, etc. So make sure you remember to do that. All right, so here I popped it in there. There's my view controller selected in the navigator. Let's make the navigator a little bit wider so you can read it. There we go. Emotions view controller. And you can see it's given me a little bit of code. These right here are part of the view controller lifecycle, which I promise I'm going to talk about right after this, but not now. And then there's this other thing that's commented out down here, which is actually really important to today's lecture. This is navigation method, which you know all too well from the last lecture. It's called prepare for segue. Okay, so this is the method that's going to be used when we segue or transition from this MVC to another one, and we have to prepare that other one to do its job. And here's where we do it, okay, in prepare for segue. So we'll be coming back and implementing prepare for segue in just a minute here. So now that we have this new class, emotions view controller, of course we have to do the exact same thing we just did, which is to go back to our storyboard, click on this view controller, go to the utilities window, get that identity inspector up, and then pick the class emotions view controller so that this is now an emotions view controller, not a generic UI view controller. Okay? So now that we've hooked that up, we can start building our UI here. So what is our UI here? It's going to be super simple. I'm just going to grab some buttons. So let's get one here. Let's change some attributes of that button. How about, let's make the font really big. Something like 40 point is probably good. Let's go ahead and make some more of them. I'm going to copy paste. Make 3 of them is enough for this demo. So we'll have one of our emotions be sad, another emotion be happy, And I don't know if this is emotion, but we'll have this one be worried. Okay, so those are going to be our 30 things that we're going to show with our face. So I'm going to select them all. I'm going to stack them up in a stack view. Let's put a little space in between them there. We'll fill equally, even though they're all buttons, so they're all going to be filled equally anyway. So we've got this nice stack view right here. Now, one thing about this stack view is, if I put it here and I go down to look at my various orientations and devices, if I go landscape here, ugh, it gets cut off, right? So I really want this stack to stay in the middle. Okay, I don't want to do the same thing I did with the calculator where I'm sticking it to the edges. I just want it to stay in the middle because I don't want the buttons to be kind of really spread out. I want them to stay kind of collected, but I want them in the middle. So I can still do that with the auto layout the same way we did in the last demo. Is I'm just going to pick up the thing and use the blue lines to indicate what I want, which is I want this in the center. Okay, so I'm holding this so that the blue lines come on in the center, and when I let go, iOS interface builder here knows, oh, he wants that in the center, so that when I go down here to this little guy again and I say reset to suggested constraints, just like I did in the last lecture, it creates constraints that put it in the middle. And we can verify that by going up to this inspector. This is the size inspector. Okay, it shows the size of the thing, but it also shows the constraints, the auto layout constraints. And this is constrained to align its center horizontally to the super view center and its center vertically to the super view center. And so now, if we do the rotation, we see that it stays in the center. Okay, so that's just, again, I'm just giving you little tastes of auto layout. I'm going to give you a whole lecture on auto layout in a couple weeks, but I'm just trying to give you a little hint about how it works for now. All right, so we have this is our UI, that's the entire UI that we're going to do that. Let's go ahead and run this. Run on an iPhone briefly here, just to make sure that we've actually put this in our UI. There it is, sure enough, I can click on it. Rotation seems to work fine. We could even check to see, does this work on iPad? Let's try this one, iPad Air. Oops, and run. So anyway, here it is. Here's our UI. It's working fine here. And we can rotate here as well and get this gigantic landscape iPad. Is there no way to go smaller? What's the smallest we can go? Scale. 25%? Oh, there we go. That's small enough. So we've got all the screen real estate here on an iPad. It'd be really great to use the split view to have these words on the left and the face that matches it on the right. And so that's exactly what we're going to do. We're going to go back to our storyboard right here and make that happen. And to do that, again, it's just a matter of dragging something out. I'm going to make my scale really small here so you can see this as we drag it out. But here we're going to drag out a split view controller because we're going to put these two MVCs in an MVC that has them as part of its view. So when I drag this out, you're actually going to see I get more than just a split view. I get some other little MVCs that come along with it here. And I don't really need any of these other MVCs that come along with it. They're trying to make your life easier, but I find that 99% of the time you don't need these other things that come with it. So I'm just going to go here and select those and delete them. So let's get rid of this one. Whoops, not the whole thing. Let's just get rid of this one. Sorry, there. And we'll get rid of this one, and we'll get rid of that one. So I'm just left with my split view controller and, of course, my two MVCs over here. So let's move this a little more over to the side here. Scroll down a bit. And now I just want to make this be the master of my split view controller, and I want this to be my detail. Whoops, other way around. This is the master, this is the detail. And also, when the app starts, I don't want it to start here, I want it to start here. Don't forget this step, okay? You want the app to come in and show the split view controller with both things, right? So how do I make this the master and this the detail? I'm just going to hold down Control and drag from the split view controller to the master. And then in here, none of these really make sense, only these two do, master and detail. So I'm going to make that one the master. It makes a little master connection there. That's not a segue, by the way. That's a kind of like, somewhat like an outlet connection, but it's a specific connection to that master var there. And this one is the detail. Okay, so I've made my master and my detail here. Zoom in a little bit. And so that's really all I need to do to get these both on screen. So let's go ahead and run, see what happens here. All right, so here we go. Sure enough, there's the face on the right, Here's the stuff on the left, and if I click this, nothing happens. Okay, face doesn't show. Now, why does nothing happen there? Because we have to do the step of having a segue, right? If we want to move to a different MVC, we have to segue to it. So each of these is going to have a segue to this MVC, and when it segues, it's going to replace that MVC with a new one that's properly prepared to show that motion. Okay, so let's go do our segues. Segues also, of course, we use our favorite gesture, which is control drag. So if I want to make a sad segue, I'm just going to hold down control and drag to the MVC that I want to segue to, the MVC I want to show when I press sad. So I do that. Now, you notice that I have some choices of what kind of presentation, what kind of segue I want. For example, present as popover would present the thing I'm segueing to in a little popover window on top of everything else. Or present modally would take over the whole screen and show the new MVC. And then there's show and show detail. So show is only used when you're in a navigation controller. You know, the thing where they've got the cards sliding on top, like the settings example I showed you. And show detail is used in a split view setting or in a hybrid setting. Okay, where sometimes you're in a split view and sometimes you're in a navigation view, which is going to be the case we're going to be in here. So show detail means show this in the detail side of a split view. So I'm going to show detail there. So I've made this segue. You see it appeared right here. This is a segue. Looks a little different from this thing, a little different icon right there. This is a segue, and you can click on it, and in fact you can even inspect it. And you must inspect it, in fact. Go to the Attributes Inspector and inspect it, because you're always going to want to give every segue an identifier. This is just a unique string that in your code you'll be able to reference to say, I'm talking about this segue right here. So I'm going to call this one my sad segue. Okay? And then I'm going to do the exact same thing here for happy. Okay, I'm going to do show detail on that one. I'm going to inspect that segue. Oh, see, there's our sad one. Notice that when you pick a segue, it shows you what it's segueing from. And if I pick this one, it shows it's segueing from the other one, so I know which one it is. So this is the happy one. And then we'll have our little worried segue. Where's that one? It's right there. Worried. Okay, so that's it. So we've created these segues. We put it in the split view first, and then we created the segues. And now when you click on those buttons, it's going to segue to this detail. And in fact, in a split view, it replaces the one that's there with a new one. Remember that segues always create a new one. Don't forget that segues always create a new one. It's something easy to forget. Especially in a split view, it looks like, oh, it just changed the one that was already there. But no, it actually completely replaced that detail segue by doing that. Okay, so if we run this, it's going to look like it didn't even work. Even though we hooked these segues up, it just looks like, oh, it's not doing anything. Watch. Okay, see, sad, happy, worried. Nothing is happening. Absolutely nothing is changing over here. Now, what's interesting is it is, in fact, segueing, and it is replacing that. The only problem is we didn't prepare that thing to show the right emotion before it showed. So it's just showing the neutral emotion, right? So it's creating a new MVC, but it's just showing neutral because it has not been prepared to be on screen. So now we have to go back to the emotions view controller here and do this prepare for segue and prepare that destination detail view controller to do what we want it to do. So let's get rid of some of the comments here just to make our code a little cleaner. Get rid of that as well. Actually, we can even get rid of that. Okay, so here's our prepare for segue with this extra argument sender, which I'll also talk about in a little bit. So what do we do in a prepare for segue? There's usually two really important pieces of information we need when we're preparing to segue to an MVC. One is we need to know which segue. That's the identifier. The other one we need to know is what's the new MVC that the system just created for us that we're supposed to prepare. Both of those things are found inside this argument right here, this segue, this UI storyboard segue. If we alt-click on it, oh, can't get it. Sorry about that. Here we go, this guy. We have the storyboard segue, and if we go look in the documentation for it, you'll see that it doesn't have a lot in there, but one important thing is the destination view controller, and one is the identifier of the segue. This is also the source, which would be the emotions view controller. Okay? So that's really just got the information that we need to prepare this thing. So let's go and first get the destination view controller. So I'm going to say let destination view controller equal the segue's destination. Oops, destination. Okay, So I've gotten that view controller. Now that is of type UI view controller. If I alt-click on that, you'll see it's type UI view controller. That's because Segway is this generic UI storyboard Segway thing. It doesn't know anything about face view controllers or emotion view controller or anything like that. So we're going to have to actually use that casting mechanism with as. Remember that as casting that we did with any and any object? We're going to have to do it here because this destination view controller better darn well be a face view controller, or I don't know how to prepare it. Okay, that's the only thing I know how to prepare this emotion for, so it better be that. Okay, so I'm going to say if I can let a face view controller equal the destination view controller as, and I'm going to do it conditionally here, a face view controller, then I'm good to go. Okay, so now remember this as kind of conditionally checks to see if it's possible for this to be a face view controller. And if it's not, my prepare is going to do nothing. And it's going to let that destination view controller appear unprepared because it doesn't know how to prepare it. Because we only know how to prepare, at least so far in our app, we only know how to prepare a face view controller. Okay, in fact, some would say don't use as with if let here. Just use as exclamation point and make your program crash if you try to segue to something you're not expecting. Because again, you'll find it in your debugging before you ship your product. So I can see the argument for that. But we'll make it so we'll just ignore it if we can't convert that destination to a face view controller. All right, so now let's check the identifier. Okay, so one thing about the identifier is someone might have forgotten to set it in the storyboard, so I'm going to do an if let on it. If let identifier equal the Segway's identifier. Okay, because this Segway identifier right here, you can see, is an optional string. So it might be not set in the storyboard. So I'm checking to make sure that it is in fact set. And now I need the expression, the facial expression that I'm going to set in this face for. This is where I'm going to do the actual preparing. And I could do a little switch or an if then else here on all the different segues, sad, happy, worried. But I'm imagining that, oh, my app might have 20 or 30 emotions someday. So I want to do something a little more extensible, similar to what we did with the calculator brains operations, which is I'm going to create a private little dictionary here called emotional faces. And it's going to be a dictionary that has strings as the keys and facial expressions. Facial expression, oops, sorry, that's supposed to be colon. No, that's right. Facial expression as the values. Okay, and I'm even going to just do put the values in right here. Okay, so this is just a little dictionary. This string is going to be the identifier here that comes back, the name of our segue, and the facial expression is going to be the facial expression that I want to use there. What's it complaining about here? Maybe because I didn't have anything in there. Oh yeah, because we have nothing in here. So let's put some things in here. Let's do sad. Okay, what's a good facial expression for sad? Well, let's create one. Facial expression where the eyes are probably, what did I say here? Oh yeah, closed eyes, and the mouth is in a frown. That sounds pretty sad all around. Okay, and then for happy, it would probably be the facial expression with the eyes open. And we want the mouth in a big smile, of course. And I think that worried, I looked at a few facial expressions. I thought worried, the best thing that looks like that was eyes open. Oops, open, and the mouth kind of in a little smirk. That face, for some reason, to me, looks a little worried. Okay, so now I've got this table, which I could add more things to over time. And all I have to do is make a new segue for it and have the identifier match the string here. Now, I might have an identifier that's not in here, so I'm going to say if I can let the expression I want equal my emotional faces here, sub the identifier, so I'm looking it up there. Okay, but it might come back nil, because we know that if we look something up in dictionary and it's not there, it'll come back nil, so that's why I'm doing if let. By the way, look at this. I have if let this, if let that, if let this. And you can imagine having 4 or 5 of these and you start getting really deep and the code is really kind of messy. You can actually just do these with commas. You can just put right here this one and then a comma, and then this one and then a comma. Okay, so you can put as many of these things as you want, and not just lets, if, let, comma, but also other expressions too, other things. Like it's almost like an and, ampersand kind of expression. And that makes it so that I don't need all these curly braces, right? I can just use this one top level curly brace. Okay, so now I have the expression. Here's where I'm going to do the prepare. I'm going to say face view controller, prepare yourself by making your model, the expression, equal this expression that I just looked up in that table. Okay? Make sense? I got no wrong curly braces? Yeah, one less than that. Okay? So that's the actual prepare. That is where I am preparing this new MVC that it created, this brand new face view controller just created with the segue. I am preparing it to do what it does. So let's see if that works. The face should be prepared now. When it gets created, we should see a face, the right face. Okay, so here it is. Let's try. Woohoo, happy. It looks a little worried and sad. Okay? Now, let's see how happy we are, though, on an iPhone. Because we know that on an iPhone, it's kind of small, split view, not really enough room for a split view. So what's going to happen with this storyboard on an iPhone? Let's find out. Okay, well, here we go. Sad, happy word. Excellent. Let's see, happy. All right, we're happy. Well, no, we're not so happy because we can't get out of here. We got this happy face, but I can't get back. Let's try going, even in landscape, no split view. So now there's no way to get back to pick any other expression. So on the iPhone, you get to pick one expression and you're done. And that's the end of the app. You have to quit the app now, because, or turn your phone off, I guess. There's absolutely nothing you can do. You're stuck. I guess you can make the eyes blink. Yeah, look at that. That's about it. So this is not a very good app on the iPhone, obviously. So what are we going to do? Since we have no split view on the iPhone, you actually can have a split view on the iPhone, by the way, but you have to do special stuff to kind of enable it. But by default, the split view doesn't work. Well, of course, Apple understands that split view is not really very good for iPhones. iPhone Plus is, by the way, it does work, and I'm going to show you that in a moment. So they know it's not that good. So if you go back to your storyboard here, so we're going to go back to our storyboard, and we're going to look at this, and we're going to say, well, on iPhone, I'd really like this UI to be navigation controller instead. Not a split view, navigation controller, where when I click on this emotion, it shows the face by sliding it on top, but I'll have a back button, so I can go back, pick a different one. It'll slide it on top, and I can hit back. You see what I mean? So I can go back and forth. And you can do that incredibly simply. You just pick this view control right here and go to Editor, Embed in Navigation Controller. And it's going to insert a navigation controller in the middle there. See that? I'll put that navigation controller in there. And what's really cool is with the navigation controller, you actually get a little title bar. And you can go straight here in Interface Builder if you want and put a title in there, like maybe emotions, we could call it. It's the name of our app, or that's what these are in this MVC, rather. So I'll put a little title in there. And that's really cool. And so now when we run, I get my face coming up in neutral mode. And if I go back, now I can pick something like happy. Now, one thing you might be interested in there is like, whoa, it came up in neutral mode instead of coming up on this page. You kind of would expect it to come up on this page, wouldn't you? And we actually made it extra credit for you to figure out how to do it. Okay? And what you need to do is something with split view controller, it's delegate, which I'm not going to talk about the delegates until Wednesday. That's why we made it extra credit. But you're going to use split views delegate and read the documentation, and you can make it so that it'll come up on either page, either on this detail page or on this master page. But you can see this is working great. In fact, we even got this nice little title bar up here, and we can switch back and forth between any emotions that we want. And let's go see what happened when we did that to iPad. Did we break the iPad? Oh, let's hope we didn't break the iPad by doing that. Okay, here we go. Comes up, there's the face. By the way, you can do split views in portrait. You just slide out. See, it slides out like a little shelf like that. Or you can rotate and see them side by side. And it's still working. So the iPad is working just fine. Unfortunately, there's no zoom level that's a better zoom level. But the iPad has a title here, but God, it'd be really cool if there was a title over here too. Like maybe this would say sad, and if I hit happy, it would say happy over here. Wouldn't that be cool to have a title on both sides of that? And that's often in split view you want, because you want kind of the balance between the two to have title on both sides. So no problem. Let's just go back to our storyboard here and select this view controller and embed it in a navigation controller. Okay? And in fact, if we go here and look at an iPad, what it's going to look like on iPad, especially in landscape, we'll see that, ooh, this is looking like exactly what we want. Look, see when it's in detail, it's got a title bar. It's got a title bar here, title bars everywhere. It's fantastic. This is going to be great. Let's do it. All right, look at that. Title bar on the top, and we broke it. Okay, so what happened there? Why did we break that? Well, this has to do with the preparation piece, and I talked about this in the lecture last time. Because what prepare is doing is it's creating a new MVC here, and then we're preparing it. The problem is that now, when it creates a new MVC here, what is the MVC? What kind of MVC is it? Anyone want to hazard a guess? Because it's not a face view controller anymore. What is it? Yeah, it's a UI navigation controller. Okay, that's the new MVC we're creating. It has a face view in it, but it's a UI navigation controller. So our code that we have back here, okay, that's doing this prepare, it says if I can let the face view be equal the destination as a face view controller. Well, it can't do that because it's not. It's a UI navigation controller instead. And I'll show you that in debugging here. Let's go ahead and set a breakpoint right here and go back over here and pick one like happy. Here it breaks. And if we look at this destination view controller, those of you who came to the debugging Friday section, we didn't really go over this cool feature, but if you just mouse over a variable, you see how I'm holding my mouse over destination view controller? You see it's showing that there? There's two really cool buttons in there. You see this one looks like an I, and this one looks like the letter I for info. If you click the one that looks like an I, it'll actually show you that view controller right there in the debugger, okay? Which is kind of cool. And if you go over here and click the other little I, it'll show you the class that it is. In this case, it's a UI navigation controller. Okay? And this works for all kinds of types. Colors, even a map location, it'll show you a map with the location on there. Okay? So this little mouse over debugging thing is really cool. But anyway, we see that destination view controller right there is a UI navigation controller. We know that's no good. So what are we going to do about this? Well, I'm going to check for this case. Okay? I'm going to say if I can let navigation controller equal the destination view controller as a UI navigation controller, in other words, if that destination is a UI navigation controller, then I'm going to grab the visible view controller out of it and use that as the face view controller, hopefully, right? So I'm going to say, in this case, I want the destination view controller, which is this thing up here, which now is going to need to be a var since I'm going to change its value here. I'm going to let that equal the navigation controller's visible view controller. Okay, now this is great. Visible view controller is a really nice method in navigation controller. It shows you whichever card stack is currently visible, exactly what I want. The only problem with it, however, is it returns an optional because nothing might be visible in the navigation controller right now. Okay, you might have never put anything in the navigation controller. So since that is an optional, I'm going to have to give it some default value. And the default value, I'm just going to say, okay, just use the destination view controller as is if I can't get the visible view controller of the navigation controller. So it's just kind of a default to use it what it already was. Basically, don't change it. So this little if is nice because now my code works if it's in a navigation controller or even if it's not. Because if it's not in a navigation controller, this is going to do nothing. That's going to fail. All right, this as is not going to work. And we'll go straight down to checking to see if it's a face view controller. So if I later came along back to my storyboard here and I decided, you know what, I don't really want the title on here, and I took this navigation controller out of the picture, my code would still work. Because my code works whether I'm going straight to a face controller or through a navigation controller. Okay, everybody got that? All right, so let's see if that indeed fixed our problem. All right, here we go. Let's try. Happy? Oh yeah. Worried? Sad. Happy? We're happy because it's working. Okay, now we have this nice title bar at the top, and we said, wouldn't it be cool if we could put a title? So let's do that. Let's put a little title here. In fact, the title I'm going to put here is whichever button brought this MVC up. So if the sad button brought it up, I'm going to get its current title and put it up here, kind of like we did in the calculator, right? Look back to the sender. And luckily, prepare for segue has the sender. This is the thing that caused the segue to happen, okay, which is going to be one of those buttons. So right down here, I can just get the current title of this sender right here and set that to be the title. Now, if you remember from the lecture about navigation controller, the way that you set things that appear when it's in a navigation controller, like the title, you can also set the buttons, the back button title you can set, or you can even put right buttons in the top. You do that with this thing called navigation item on a UI view controller. So I'm going to take the face view controller's navigation item, which, by the way, the navigation item, you can just kind of think of it as a bag of goodies that only UI navigation controller uses. And it only looks in that bag of goodies when this view controller, the face view controller, is the visible view controller in the navigation controller. Then it looks in this bag of goodies. And you can see there's a lot of things in the bag of goodies, like left bar button item, right bar button items, and of course the title, okay, which is what I want to set here. I want to set the title of the navigation controller when this thing is visible. And I'm going to send it, I want to send it to the sender's current title, but I can't quite do that. Okay? Why can't I do that? Why is that not going to work? You know? This? See any problem? Yeah, this is any. And any doesn't understand any messages, okay, because it doesn't know what it is. So we have to take this any and turn it into a UI button. Okay, and we do that by saying this, sender as a UI button. Okay, now we could almost send current title. The only problem is this. What is this type of, what is the type of, if I can select it, this expression? What's its type? No one want to guess on this one? No one? It's an optional. Right, because as question mark returns an optional. So this is an optional, so we can't send an optional current title. We need to either exclamation point it, or a little safer, we could optional chain it. Okay, because we know that optional chaining is just going to ignore the rest of this expression if that happened to not be a button, and this as returned nil, because this couldn't be turned into a button. So we'll just optional chain, in which case the title here will be set to nil, because this whole thing will be nil if this optional chaining doesn't happen. And that's okay, because if we look at the title of a navigation item, it's an optional. So we can set it to a nil, and then it'll have no title up there. Okay? I intentionally put this in here for a lot of things going on here. Okay, we have the any cast going on, we have optional chaining going on here, we're using the navigation item, so there's a lot in this line of code. So make sure you kind of understand what's all the pieces going on there. All right, so we'll go run. Now we should be getting, hopefully, the title of the button appearing as the title on the right-hand side. So happy, and sure enough, there's happy. Worried, there's worried. Sad. Okay, happy. And of course, if we rotate, we're still getting the title up there. We can slide this thing out and pick sad, and it happens back there. Okay, we can slide that thing out of the way if we want. Rotate back. How about iPhone 7? Let's see, have we broken that? Okay, it appears with the split views detail coming up first in this neutral mode. We'll go back to emotions, pick happy. Sure enough, it's setting that title fine there as well. If we go here, since it's an iPhone, can't do split view, it's still working fine in navigation controller mode. Let's go look at a 7 Plus. Because a 7 Plus is kind of a hybrid between an iPhone 7 and an iPad. And in portrait mode, an iPhone 7 Plus works just like an iPhone. So it's going to be navigation controller back and forth. But in landscape, it'll work like an iPad. Okay? So, you know, obviously an iPhone 7 Plus in portrait mode is not big enough to do the slide out thing like an iPad does in portrait mode. But in landscape mode, it is. So let's make it so this thing fits. That's close enough to fitting. Yeah, I'll sure I'll go so small here. All right, so this is a plus, and you can see it comes up in portrait mode. It's acting like it's an iPhone. See that? Okay, it's just doing that. But look what happens if I go to landscape mode. I get a split view. That's working fine. Okay, so you see how we built in the storyboard this hybrid UI, and it works on all the different kinds of devices. No matter whether they can show split view or not, it'll go back to using navigation controller or whatever. And the only thing we had to do in our code as a concession to the cross-platform is checking for that navigation controller, and only for the thing we were segueing to. All right? Okay, that's it. Back to the slides. There's those, there they are. Okay, our next topic here is the view controller lifecycle. Now, everything has a life cycle. Even we have a life cycle. We're born, we live our lives, things happen, and we die. Well, that happens to a view controller as well. It is born, things happen to it, and then it dies. It leaves the heap. That's what happens on its death. Why do we care about the view controller life cycle? Well, because we often want to do things at various key inflection points in its lifetime. The start of a life cycle is really simple. It gets initialized. And this 99.99% of the time, a view controller is coming out of a storyboard. Okay? So its initializer is this special initializer for coming out of a storyboard. In your reading assignments, I actually explained how this works. But we don't usually override the initializer of a view controller. We're going to use the other ways we know to initialize its variables. Okay, so it comes out of story. I'm not even going to talk about how to make one in code because we just don't do that. You can see why, right? Because view controller is complicated. It's got all the UI, the buttons, and all this stuff. You're generally not going to be making that in code. All right. So what happens then after it's created? Okay, the next thing that happens is if it's being segued to, it gets prepared. Okay, like we prepared the face view controller there by setting its model. That's the next thing that happens after it's initialized. Then the next thing that happens is its outlets get set. So for the face view, its face view outlet got set after it got prepared, by the way. Then it appears and disappears on screen. Okay? Now, in our example right there, the master was constantly appearing and disappearing on screen. Every time on the iPhone, for example, that we hit happy or sad, it would disappear and the face one would come on. And then we'd hit back and it would reappear. By the way, when that happens, the face one didn't disappear. Well, it disappeared, and it also got thrown out of the heap, right? Because we reuse the things we segue to. But that master, we don't segue to it. It sits there as the master in the split view all the time. Okay, but it's appearing and disappearing on screen. So that's a big thing that happens in its life cycle. Another thing that happens during the lifetime of it is it's changing its orientation. We're rotating the landscape, okay? We're on an iPad and we're sliding it out as a tray in portrait mode, and then we rotate the landscape and it's sitting on the side. So it's changing its shape. Even the face view on the iPad, when we're in portrait, it's big, tall and big, but then when we switch to landscape, it's kind of more like a square and a little smaller, right? So it's always changing geometry. And then it could be in a low memory situation as well where we need to recover some memory. This almost never happens, but I have to mention it. It's really maybe not even part of the view controller lifecycle, but it's a good place to talk about it because it's not really that important. All right, so let's talk about the methods then or the messages that are sent to invoke methods in your view controller when these various things happen, okay? So you already know about your outlets being set, right? And you can watch that with your did sets, the property observer did set. And you already know about preparing. I just showed you about that. So after those two steps are done, you're going to get this message, view did load. Super important method, okay? You're only going to ever receive it once in the lifetime of a view controller. And it's really where you're going to put almost all of your initialization. For example, a lot of times, here's what you'll call your update UI method, right? The thing that updates your UI from your model. Very often, you're going to call that in view did load. Okay, because now your model is set because it got prepared probably, and your outlets are set because this is how always happens after outlet setting. Now, one thing not to do in here, though, very careful, listen carefully, do not do geometry-based things in view did load. Because when view did load happens, you have not yet had your final geometry established. Okay? You don't quite know if you're portrait, landscape, what device you're on. You don't know yet. So do not do things with your bounds in view did load. And many of you will make this mistake. So perk up those ears. Okay? Do not do that. I'm going to show you other methods in the view controller lifecycle for doing that, but do not do it in view did load. Okay, now the next thing I said is you appear and disappear. You're always appearing and disappearing on screen, okay? Well, when you appear, you're going to get two messages. The first one is view will appear. And that's sent to you before you're actually on screen, all right? But you're very, very soon going to be, okay? Guaranteed you're going to be on screen soon. So what's view will appear for? What are you going to do in a view will appear? Well, one thing is if there's anything that changes in your model when you're not on screen, maybe your model is a network database or something and it's changing on screen, then when view will appear happens, you're going to usually update your UI from your model. So maybe you wouldn't do update UI in view did load, you might do it here. Okay? That's if it could change when it's not on screen. A lot of MVCs, their model only changes when they're on screen, so you wouldn't have to do anything here. But if your model can be changed out from under you while you're off screen, then when you reappear, obviously you want to show the current state of your model. So that's a good one. Another thing you might do in View Will Appear is start something expensive. Because in View Did Load, you're not guaranteed that you're ever going to come on screen. There are MVCs that occasionally get loaded up, but then the user clicks away somewhere else and you never get shown on screen. But if View Will Appear happens, you know you're going on screen. So here you could kick off something expensive. All right, especially kick off a thread that goes and does something expensive in the background. Because we're going to talk about multi-threading next week. And you're going to see that anything that takes any amount of time or energy on the part of the processor or the network, you're going to want to do in a separate thread. So you might kick off such a thread here in View Will Appear. There's also another method, View Did Appear, which gets sent to you after you're fully on screen. The animation to get you on screen is on screen, so you're there. And what would you do here? There's usually not a lot to do here. You might start an animation, though. Right? You've got some MVC that has some animation going, and it doesn't make any sense to start it before it gets on screen. So once it gets on screen, then you start it going. Right? I mean, View Will Appear and View Did Appear happen so close together, probably not going to save much to wait till View Did Appear to start the animation, but a lot of people will do that just kind of for clarity of programming. And then, of course, you can disappear, and you get the same thing there. A view will disappear, and a view did disappear. Now, one thing you notice, by the way, in all of these view controller lifecycle is I'm calling super. You see that? Super view will disappear, and I did it for super view did load and super view will up here. All of them, all of the view controller lifecycle methods always call super. Okay? You always want to give your super class a chance to do it. You'll see actually in the demo why you do that. But always do that. Always do super there. Okay? So in View Will Disappear, a lot of times here you're undoing the things you did in View Did Appear. Like if you had an animation going, you're going to stop it here because you're about to disappear. Okay? Here you might also start some cleanup. Your MVC disappeared, and so if you allocated some resources or something that you don't need, network connection open or something that only makes sense to be open while your MVC is on, then here's a good place where you can shut it down, and there's a did version of this as well, right? A lot of times people look at View Did Appear and View Will Disappear as matched. One undoes the other, and then same thing with View Will Appear and View Did Disappear. Those are going to undo each other. All right. Still haven't talked about geometry till now. So you don't want to be doing geometry in View Will Appear. Your geometry actually probably is set in View Will Appear, but you shouldn't count on that. Shouldn't do geometry in the View Wills and Did Appears and Disappears either. Geometry changes, there's methods especially for it. One thing to consider is you almost never need to write any code when your geometry changes. That's because you have auto layout. I mean, look at the app I just wrote. I've got that sad, happy, worried block of text, and when I rotate, it stays in the middle. I didn't have to write any code for that. And even more complicated UIs, you're usually using auto layout, and it's doing it for you. Okay, so most of the time, you don't need any code. But if you did feel like you needed to do some code, let's talk a little bit about how you do that. Okay, there's two methods, View Will Layout Subviews and View Did Layout Subviews, and these are sent to you. In between these being sent to you, auto layout happens. All right? So if you want to get involved in the geometry change of your view before auto layout starts, you can do it in View Will Layout Subviews. If you want to wait till after auto layout does what it does and then you want to get involved, you can do it in View Did Layout Subviews. So when do these get called? So when a bounds of a view changes, all of its subviews might have to be moved around. Okay, maybe the view is now tall and thin instead of short and wide, okay? So its views are going to have to be moved to be in the right place, just like, again, we rotated the emotions thing, and we need to move that stack view up or over a little bit to stay in the middle. And so that's primarily what's going on here. That's why this method is called View Will Layout Subviews. Okay, its bounds changed, and now all its subviews need to be laid out. What about the things the view actually draws itself, like the face? That has nothing to do with this. Okay, that's a view thing. Okay, that face view, when the bounds change, if its content mode is redraw, like we said it for the face view, its draw methods automatically get called at the new bounds. Okay, so you don't have to do anything there. So View Will Layout Subviews is what happens when you have subviews. Now, this happens at the view level, so views have a method for laying out their subviews. It's called layout subviews. And the view controller also gets to find out when its view, and by this I mean the var view in view controller. Remember what that var is? That's that top level view, right? There's a var for that in your view controller. It's saying that view is going to lay out its subviews. And that happens when that top level view changes, usually due to rotation, but other things can change it as well. Okay? Now, one thing about these methods is you should expect that they might be called all the time. You don't try to anticipate when they're going to be called. Just whenever they're called, you do what you're supposed to do. And they might be called repeatedly with the same bounds. So the bounds might not actually have changed. Because this is not called view bounds change. This is called view will lay out subviews, and view did lay out subviews. And there are other things besides bound changes that might cause that top level view to have to lay out its subviews. So expect this to be called fairly often, and you should always react to it correctly, okay? Even if it's called repeatedly with the same bounds or whatever. Now, auto rotation, okay, the bounds changing by rotating the device, actually has a couple little extra pieces of interest to it. The most notable is animation. Okay, so normally when you rotate, it's just going to be view will lay out subviews. Everything's just going to auto layout's going to happen. Everything is happening fine. However, that changes, all those changes are animated. If you look closely when you rotate your device, all the views are kind of flying across to their new location. It's really kind of cool, actually. Okay, they kind of, they're being animated. They don't just appear in the new place, they slide over. Well, you can participate in the animation. Now, we haven't talked about animation. We will in about 3 weeks. But you can participate with this method. View will transition to size with coordinator. And that coordinator has a little closure you can set on it that will cause some animation you want to do to happen alongside the rotations animation. Okay? So if you want to animate moving some subviews or doing something else that doesn't happen automatically for you, which most stuff does without a layout, you can do that here with this method. Okay? Yes, that's what I just said. Okay, low memory. Okay, so did receive memory warning would be sent to your view controller when the system's low on memory and is trying to get some back. This almost never happens. I just can't even remember the last time this happened because the device has so much memory these days. Usually if this happens, though, you want to pay attention because you're using a lot of memory. If the system is sending this to you, either you are or some other app is using a lot of memory. By the way, if you're an app that uses a lot of memory and you don't keep it under control, the system has the right to just kill you. Okay, just kill your app. And it will do it, absolutely. Even if you're in the background. If you've allocated a ton of memory and you're being a bad citizen, it'll just kill you off to get your memory back, okay? What kind of memory would you free up if you got this method? Okay, let's say you had an image that's not currently on screen, and you can create it from a file on disk. Okay, we haven't really talked about that. These are the disk, but your phone has permanent storage, flash memory. And you have, let's say, a JPEG image, and you can just recreate it. Well, you would definitely release that here, because it's not on screen, and you can create it real fast from the disk, so there's no reason to keep it around. So that's something you could release. Basically, any memory that you can quickly recreate, or that is not currently on screen, and you can create it when that comes back on screen, that's a good thing to release, but only big things. Don't do little tiny 100-byte things. No, we're talking images, sounds, videos, big old things, okay? All right, there's one other little thing that's not part of the view controller lifecycle really, but just every single object that comes out of a storyboard, views, view controllers, everything, gets sent awake from nib. And they get sent it pretty early, okay? Like right as soon as they come out, they get this awake from nib. Now, you can't use it to like satisfy the requirement that all vars are initialized, okay? But you can use it to do really early initialization. For example, remember I mentioned about you want your split view controller to come up showing the face, or showing the emotions instead of showing the face. So in your calculator, it would come up showing the calculator instead of the calculator's graph. And I said you needed to do that by setting a delegate, this delegate of the split view controller. That's something you might want to do in awake from nib. Just really early, get that delegate involved early. We'll talk about delegates on Wednesday. So awake from nib, rarely used and sometimes overused. I would say if you can put it in another method like view did load or view will appear or view did layout subviews, put it there first. Don't put it in awake from nib. It's kind of a last resort place to put things. It's probably better than overriding init, but that's the only thing it's better than. All right, so here's the summary of the entire view controller lifecycle. You get instantiated. okay, created out of the storyboard. You get a wake from nib sent to you. Segue prep happens. Somebody prepares you if you're being segued to, which most MVCs are. Outlets get set. Your face view in your calculator, it's your display and things like that get set up. View did load gets called. Okay, so this is, again, view did load. Look at all the things that have happened by the time view did load gets called. It's a great place to put initialization. Now you enter kind of the normal life cycle where you're getting appearing and disappearing with the will and did appears and disappears, right? And along the way, and at any time actually, even before view did load, you can even get these sent to, although that would be rare. But anytime you can be, actually I'm not sure you can get it before view did load. I'm going to take that back. But anytime when view will appear and disappear is happening, whether you're on screen or not, you could get view will layout subviews and view did layout subviews sent to you. And auto layout happening. By the way, why would you ever be sent these methods when you're not on screen? Well, the system might be preparing to animate you coming on screen. Okay, now when the system animates things, one of the ways it can do it is have you draw in one orientation, have you draw in the other, and then it kind of moves the bits from one to the other. That's one kind of animation can do. So you might be off screen and it's asking you for both of those. So it sends you this twice, once to get in this orientation and draw, and then once to get in this orientation and draw. And then when you come on screen, it animates you from one to the other. See what I'm saying? So that's why you can get these at any time, on screen or off. And then also at any time, you could get a low memory warning. And then you're done, okay? Your thing goes away. It leaves the heap when it goes off screen if it was segued to, okay? If it's, as long as it's not itself segueing to something else. But when it's done, it gets thrown out. Okay, so I'm going to show you a demo that will make all this a lot more concrete. And what I'm going to do, yeah, let me go through the rest of this in case I don't get back to the slides. I think we will, because I think we're going to have time to do this other topic. But so yeah, after the demo, I'll come back and talk about memory management, hopefully. On Wednesday, extensions, protocols, delegation, that thing I was telling you you'll need to know for your split view thing if you want to do that extra credit. And we'll start talking about scroll view, more complicated object. On Friday, important one on Friday if you want to do the extra credit about performance in the calculator graph. So you definitely want to show up for that one. And then next week, we'll start into multi-threading, table view, a whole bunch of cool stuff. All right, so let's do this demo here. I'm going to go to our face view, same thing we were just in, this Faceit app. And I'm going to drag in a little piece of code I wrote, which I'm going to show you here. Let me, let's get our navigator back here. Put this in here. So I'm just going to drop this in here. By the way, when you drag in code, you probably want to do copy items if needed. Otherwise, it's going to be kind of linked to the other one. If you change it in the other place, oh, it's going to be changing here. It can be kind of causing unexpected results often. All right, so I put this in here. So let's look at this little class I just dropped in here. It's called VCL Logging View Controller. It's a subclass of UI View Controller, okay, called VCL Logging View Controller. And it logs the VCL methods, View Controller Lifecycle methods. So it just, see, it basically just overrides every single one, right? View will appear, view will layout, subviews, view did load, wake from nib, even tells you when it left the heap, okay? It's overriding init here, and it just prints out what happened, okay? So it just sits there on the console printing out everything that happened. It's a little bit cool because it shows you the instance of each of them, so you can see instances coming and going as they get segued to and then come off. It also kind of indents it over time, so you can, when you click something, you can see a bunch that happened together, okay? Now, the way we're going to use this is we're just going to make this class be the superclass of both of our controllers. So we're going to make that into a VCL Logging View Controller, and we're going to make this into a VCL Logging View Controller. And right there, you can see why we always want to call super in all of our view control methods. Because if we did any of these view controller lifecycle methods and we were subclassing from VCL Logging View Controller, if we don't call super, it's not going to get logged. And it's not unusual to come along later and pop a different kind of view controller in between you and UI View Controller, some view controller that does something like logging or something else. Okay? All right, so that's it. That's all we need to do to make this work. So I'm going to go ahead and run. We'll stick with iPhone 7 Plus. Let's go ahead and get the console up here. Get all console all the time here. All right, and here we go. This came up, and we're already seeing a lot of view controller lifecycle stuff happening here. All right, we have our emotions view controller and our face view controller. These two view controllers get initted. They come out of the storyboard. Okay, and you get initialized with this init with coder. That's the one for things that come out of Interface Builder. They both get awake from nib. You see that? And then the emotions one first gets view did load. Then it gets view will appear animated false. That's because we're just starting up our app, so it's not sliding in on a navigation controller or something. It's just boom, appearing, so it's not animated. Then notice it gets laid out twice, both at the same size. 295 by 414, which is this size right here. It gets done twice. Again, why? Some animation. I don't know what's going on, why it's doing that, but you don't care. Just be careful that those layout subviews can happen repeatedly. Now here's face view controller. It gets loaded. Okay, it's told it's going to appear. It will appear, and it gets laid out once. Okay, then they both did appear, and now they're on screen. So this is kind of exactly what you expect, right? Now let's rotate this thing so that we go to portrait mode, and we're not going to see the master, right? We're only going to see the details. See which way is this? This way is. Okay. So here the master disappeared. So this is, see the dash? That's what happened when I did that rotation. Okay. This is all the new stuff. Now notice that the emotion view controller immediately is told that there's going to be a rotation animation. Okay, and it gets a chance to participate in that animation. The face view gets relayed out in its new size, right? It's tall now, so it gets laid out, so it gets view will layout subviews. The emotions controller is told that it will disappear. Okay, so it's going to disappear. Notice that the animated false, that's because the animation in that rotation case is handled by the rotation animation. So it's not sliding in or out, but it is getting animated out of there, but by the rotation animation. Then we have the face view controller being laid out again. Okay. Face view again. Now we're getting the emotions view controller getting its chance to animate alongside the rotation right here. We've got a couple of spurious things here from the iOS UI kit. You can ignore those. And then the animation ends for both of those controllers. Okay, that makes sense? Now I'm going to click this emotions thing and go back to the master and watch what happens. Okay, so we go back to the master. Face view controller was told it would disappear, of course, because it does disappear. The emotions one is told that it will appear. It's laid out in this new tall arrangement. And then the face view controller told it was disappeared, and the emotion view controller was told it disappeared. Okay, now let's go bring one back. You can see, look, face view controller sub 2. A new face view controller was created because we segued to it, so it created it. You see that? And in fact, if we go back and forth, we'll see that we're getting new face view controllers each time. Face view 3. And look at the old ones. Face view controller 3 left the heap. They're getting thrown out of the heap. All right? So I'll be posting all this code. You can drop this logging view controller. Actually, you could drop it into your calculator if you wanted and try and watch it bring things on and off screen, etc. Okay? All righty. Let's go back to the slides here. Talk about our next topic, which is memory management. Okay, we've kind of avoided this topic so far, but it's an important topic. If you have a reference counted data structure, a class, that's the only reference, well, not the only reference counted data structure, as you'll see in a second, but if you have a reference counted thing and it lives in the heap, how do you know when to get rid of it? Okay, we saw in that demo I just did, the face view controller left the heap. Okay, how did it know to leave the heap? Because, we don't do anything to tell it to leave the heap. We just, using it, and when we're not using it anymore, it goes away. Well, of course, one way to make things leave the heap. It's called garbage collection. How many people know what garbage collection is? I've heard that phrase before. See, more than half of you, so that's good. And just so runtimes like Java do garbage collection. It's perfectly fine, I guess, way to do it. It involves going through the heap and kind of marking the use of everything and then sweeping through and getting stuff that's not used. Swift doesn't do any of that. It uses a totally different mechanism called automatic reference counting. Basically, every time you create a var or a let that points to something in the heap, Swift goes over somewhere and makes a mark. oh yeah, there's another one, there's another one. And it keeps track of it until there aren't any more of those lets and vars. No, it erases them as those vars go away. Like maybe they're a var in another object that leaves the heap. So now that var is no longer pointing to this other object. So it's basically keeping track of all the vars and lets that point to something in the heap. And when no one points to it anymore, it lets it out of the heap. Okay? Now, why is this good? It's very predictable memory usage. You know exactly when things are going to leave the heap. They leave the heap as soon as nobody points to them anymore. What's also great about it, you almost have to do nothing in your code to make this work. It's just automatic. That's why it's called automatic reference counting. You can get involved, however. And the way you can get involved is by influencing the way that arc works. And you do that with 3 keywords in Swift called strong, weak, and unowned. And I actually told you I was going to tell you about these back in the very first lecture. You remember when we made the outlet for display? It was weak. Remember that? That's this weak right here. Okay? So there's strong, weak, and unowned. So let's talk about each of those. Strong, this is normal reference counting. If you have a strong var, a strong let to something in the heap, then that thing will stay in the heap as long as that var exists. It's strongly holding that thing in the heap. This is the default. You don't even ever type this keyword because it's the default. Okay? Every var, unless you say it's weak, is going to be strong. Okay? So it's simple, works magically. Then there's weak. Now weak is a really interesting keyword in Swift. Okay? When you put weak on top of a var, it says, well, I'm looking at this thing in the heap, but if no one else is interested in the heap, then you can throw it out of the heap and set me to nil. So weak only works with what type? Optional, exactly. Because you have to be able to set it to nil. Okay? So only optionals can be weak. So the display outlet in your calculator, that it was a weak UI label exclamation point, which means it was an optional UI label, okay? And so it was weak. So what does that mean? That means if that UI label, for some reason everyone else threw it out, then that display var would be set to nil automatically. Now, why does that display var set itself weak? Why does it say weak? Well, because the thing it's pointing to is that view hierarchy, right? The view hierarchy that has all the calculator's buttons and the display and all in there. And if that view hierarchy stops pointing to it, that means it's gone, okay? And so the display outlet is no longer interested in trying to set numbers in it and things like that because it's gone. So when you have a var that points into a very strongly held data structure that you completely depend on for your semantic meaning to mean anything, then you can make it weak, okay? And so we're perfectly fine if that display gets set to nil if the view hierarchy no longer points to that UI label because it's probably meaningless at that point, okay? So we don't usually use weak that much. A lot of times we'll use it to keep from having one object pointing to another strongly and having that object point back to this one strongly. Okay? That's a very bad situation. That's called a memory cycle. Okay? And that's going to keep both of those objects in the heap forever because there's always going to be a strong pointer to each of them because they each point to each other. So neither of them can leave the heap and free up their pointer to the other one unless you set one, like they're optionally set one to nil or something. So if you had a situation like that, you could use weak to break that cycle by having one of the pointers be a weak pointer. Okay, that would allow it possibly to happen. And I'm going to show you an example here of another case where making that kind of memory cycle is super easy. And that's bad that it's easy because you can get these cycles where things are being held in memory. The last one is unowned. Unowned means, hey, automatic reference counter, don't worry about this one. I'll take care of it. I'll make sure I never use it when it's not pointing to something in the heap. Okay, this one can be quite dangerous. Okay, we almost never use this. It would really only be used to break one of these memory cycles, and it can only be used to make a memory cycle when you're 100% sure that you know who's using that pointer, because automatic reference counting is not going to be counting it as a strong reference, and it's also not going to check. And so if you use it, and that thing that you're pointing to has left the heap, it will crash your program. Okay? So that's what unowned is. Now, since unowned just crashes your program if you try to use it and it's not in the heap, it's not an optional. There's no setting it to nil. It's always assumed to not be nil. And if it's ever nil and that code executes, bam, it crashes. So unowned, I will show you how we use unowned in a moment. It's only to break cycles. Now, closures have an interesting attribute about them, which hopefully you read about in your reading assignment, that really has a lot to do with this strong, weak, and unowned business, okay? And what goes on inside of a closure is that a closure captures all the references inside of it, okay? It captures them and makes a strong pointer to them. Okay, so if you reference something inside a closure, remember what closures are, right? You open curly brace and we have some code in there like we had in our operations table of our calculator brain. So inside that closure, inside those curly braces, you reference some reference type, something that's in the heap. That closure is itself a reference type. It lives in the heap, and it's going to keep a strong pointer to the other thing. And the problem comes if that other thing has a strong pointer back to that closure, because now you have a memory cycle. The closure is keeping that object in, and that object that has a pointer to the closure is keeping the closure in. They're keeping each other in memory. Now, neither of them can ever leave. Okay? It's called a memory cycle. It's really easy to create a memory cycle in a closure, as you will see. So here's an example with our calculator. Let's say I added a new method to my calculator brain called add unary operation, where I allow people to add new operations to my operations table. Okay, right now we don't allow that because it's all private, right? But let's say I had a public method, add unary operation. You could add a new operation. Wouldn't that be cool? Yeah, that would be cool. And let's see what it would look like for a view controller that wanted to, for example, add a unary operation which is square root, but it turns the display green. Okay, I call it green square root. So what it would look like to write something like that? Well, I would call add unary operation, give it some symbol. I'm going to have it look like kind of like a green square root. That's pushing it there, but that's kind of what it looks like. And it would pass in the operation for green square root. Okay, now just a couple of cleanup things before that here. This is that operation argument to add unary operation. And as we know, we could use trailing closure syntax here to get rid of that operation colon. You see, we just close it, and since the closure is the last argument, we just put it after the end of the parentheses. Remember that from when I talked about filter and map? So we could do that here, so that cleans it up. Also, of course, we could let Swift infer the types here and just use $0. Okay? Everyone understand this code up here? Could not be simpler, right? I'm just adding this unary operation, green square root, and all it's doing is setting, I'm doing this from my view controller, so it's setting the display's color to green and returning square root. It's the same as square root, but it sets the display green. Now, this will not compile. Okay, why will this not compile? Let's look and see why not. It's because it's going to say, you have to explicitly say self dot there, because I want you to understand that you are capturing a strong pointer to yourself in this closure, so that in case this closure is somehow you point to this closure, which our view controller does, because our view controller has the calculator brain has the operations table has this closure in it. You see? So I'm pointing to that indirectly from my view controller, and it's pointing now back at me, self dot. It's going to capture self. Self is a pointer to myself, my own view controller. Now I've created a memory cycle. Everyone understand what's going on there? Right? The closure lives in the heap. The view controller lives in the heap. They're now pointing to each other. The closure is pointing directly to the view controller, and the view controller is indirectly pointing to the closure through the calculator brain, through the operations table, this operation that it got added. Okay? So let's talk about how we break this cycle, because since this is so easy to do, we need to be able to break it easily as well. Well, first thing we're going to do is we're going to create a special local variable. Okay? So closures allow you to, before the word in, put open square bracket, a list of special variables. These are just little local variables that just live for this closure only. Okay? Now these variables can have any name, and you can set them to any value you want that's in the scope here. So I've created a local variable called me, and I've set it equal to self. Okay? So that's fine. Me is a local variable. It's going to be of type view controller. It set it to myself, and so now I can use me in there anywhere I use self. So I've replaced self with me. Okay, well that doesn't help break our cycle at all. However, what if I made that me variable, not self, but me, be unowned? Okay, if I make that thing be unowned, now it's not going to create that strong pointer. Okay, because me, it lives in the heap, but automatic reference counting doesn't reference count it, so it pays no attention to it. Now, what that would mean, though, is that if this code were executed and me, which is the view controller, because I set it equal to self, if the view controller were out of the heap, this would crash. But that's perfectly fine here. Do you see why that's fine? When would a calculator operation ever be executed if the view controller is not even in the heap? It's impossible. The view controller provides all the UI that causes this thing to be executed. There's absolutely no way that can happen, so it's perfectly fine to say unowned here. Okay, and that would break the cycle nicely. But let's talk about another way to do it. Oh, by the way, it doesn't have to be called me. I could say unowned self equals self. In other words, the local variable can shadow or have the same name as the more global variable self. So I could say unowned self equals self. And in fact, if I just say unowned self, that's the same as saying unowned self equals self. So this is a lot of times how we'll break a cycle. We'll say unowned self. And that basically means inside this closure, you can assume that self is in the heap. All right? Now, let's talk about breaking it with weak. So I can also say weak self. Okay? And that means that self is now a local variable in this closure that's an optional view controller. And if that view controller is not in the heap, this variable self, which is different than the global self, is going to be nil. So this is a safe way to do it. But of course, since it's an optional, we can't just say self.display right there. We have to say optional chained self.display. So that if this closure executes and the view controller is not in the heap, self question mark will be nil and it will not execute the rest of that line. It'll still return the square root, but it won't turn the thing green because this view controller is not even there. All right? So that's how we can use weak to do it. And sometimes we'll use weak, and we could create another variable, and often we'll do this. This might be the most common way to do it right here, is to say weak self equals self. And so weak self is this argument, is this local variable inside the closure only that is a weak version of self. Okay, that's kind of clearer what's going on than if you just say weak self, then it's like, oh, self is an optional, it's weird. Now at least you have a different variable called weak self. All right? Okay, so let's go in the last couple minutes and just do this in the calculator. Let's do exactly what I talk about, this green square root. I'm just going to go back to our calculator here. Where's our calculator? Here somewhere. There it is. Ooh, we haven't seen this code in a while. Well, you've seen it a lot. I haven't seen it in a long time. All right, so here's our calculator, and I told you I'm just going to add this new func, add unary operation, and it's going to take the symbol that we want to do to be the symbol, so it's going to be like the green square root or whatever we call it there. And actually, probably we want to say something like named symbol. That's probably a little better naming there, and that's a string. And it's going to take an argument, let's make more space here, which is the operation. We don't really need to have an external name because we're probably going to use closing, trailing closure syntax there to do it. But this is just a double, returns a double function. Hopefully you're all very familiar by now with using a function just as a type right there. Okay? So we have this unary operation, and all we need to do to make this work is we have our operations table down here. I'm just going to say operations sub that symbol equals an operation.unary operation, where this operation is the argument. I mean, it couldn't be simpler. Really, that was so simple because we built such a good data structure here to store all of our operations. Now notice we have an error here. You see, this has an error. What's it saying? Mark this method mutating, okay? Why is that? Well, that's because we're changing this operations table, so of course that has to be mutating. All right? But that's not only error. We got another error. What's this saying? It's saying here that this parameter operation is escaping. What does that mean, it's escaping? Let's go ahead and fix it. It puts this word in here, escaping. Escaping means that this function is escaping these curly braces. Okay? And it is, in fact, escaping. Where's it escaping? It's jumping into here. Okay? Anytime you have a function that you pass in and it gets put in some other data structure, in other words, it escapes out of the curly braces of the method it's in, you have to mark it escaping so that you understand and Swift understands that you are storing that somewhere. Okay? And that's because it might create a memory cycle if you do that. Okay, so the fix-it will automatically remind you about this, so you don't have to remember that so much. All right, so we got this nice, cool new feature. Let's go to our view controller and add it. Hey, how about we use view.didLoad? Yeah. Okay, here's view.didLoad, super.view.didLoad, and never want to forget that. Okay, so that's going to happen after we're all initialized, basically, our outlets are set. Let's just go ahead and call that add unary operation here. What is it called? Brain add unary operation. That's not seen, right? Is that what I called it? Add unary operation? I don't know why that's not. Oh, there I did it. Okay, just was a little slow. All right, and so the unary operation takes the symbol, which is named, and I'm going to go ahead and do that green exclamation point if I can find it here. Where is that thing? Oh, it's probably pictographs, maybe. No. Situation. Anyone know where that would be? Let's see. Let's try. What's it called? Check mark or something. There it is. Okay. There's our nice symbol right there. And let's go ahead and add that to our UI as well. Let's go over here to our storyboard. We'll add it instead of pi. So we'll get rid of pi, and instead we'll put that operation in there. Oh, hello. What was it called again? Check. There. Oops. Did it go in there? Two of them. Okay, so we've got this new green square root. We still have the old square root as well. But we have to add this operation, and I'm going to use that trailing closure syntax right there. Right? And of course, we know it's a double, takes a double, and this would be where the stuff goes in there. But we can let Swift infer this and just use $0, square root of $0. Okay? So we've done everything except for the green. But everyone agree with this? Makes sense, right? I'm adding this unary operation named this symbol. And here's the second argument put on the trailing closure there. So how do we turn it green? Well, we just say display.textColor. Turns out UI label has a text color. Equals UIColor.green. Okay? Now, when we put this in here like this, it's going to complain. Why? Because reference to property display enclosure requires an explicit self dot to make the capture semantics explicit. This is Swift saying, watch out. Okay? If you do this, you're going to capture self right here. Okay? And that is going to create a memory cycle. Because this closure right here, which lives in the heap, is pointing to self. This add unary operation is going to cause this closure to be put in the operations table, which is pointed to by the view controller. Now they point at each other. Let's see, what else what did I forget here? Missing return. Oh, yes, return square root, right? It returns a double. Okay, everybody cool with that? Now, to break that cycle, we could say unowned self in. That's one way to break the cycle right there. We could say weak self equals self. If we do this one, though, we're going to have to go here and say weak self question mark. Okay, either of those will break this cycle. In your homework, I've updated your homework to say you cannot have any of these cycles in your homework, okay, in assignment 3. It's in the evaluation criteria down there. So I posted on the forum for that too. So let's go see if this works. By the way, what happens if we don't break that cycle? Well, view controllers will just start accumulating in memory, okay? Because they'll be keeping, these closures will be keeping them all in memory. If you, for example, had a calculator view controller that was being pushed onto, segued to, and then segued away from, it would not go out of the heap. It would stay in the heap in that case. Right, here's our calculator. So we, 81 square root is 9. Green square root, woohoo, square root, and turned it green. Okay, that's it. See you next time. If you guys have any questions, I'm here as always.
For more, please visit us at stanford.edu.